Hi guys, and today I'm going to be solving the USACO 2018 January Contest Silver Problem 2, Rental Service. So, Farmer John realizes that the income he receives from milk production is insufficient to fund the growth of his farm. So, to earn some extra money, he launches a cow rental service called USACO. So, he has N cows up to 100,000, each capable of producing some amount of milk every day, and the M stores near Farmer John's farm up to 100,000, each offer to buy a certain amount of milk at a certain price. Moreover, Farmer John's R neighboring farms, also up to 100,000, are each interested in renting a cow at a certain price. So Farmer John has to choose whether each cow should be milked or rented to a nearby farmer, help him find the maximum amount of money he can make per day. So let's take a look at the inputs here. So N is going to be 5, M is 3, and R is 4. Which means there are going to be 5 cows. There are going to be 3 stores that are willing to buy a certain amount of milk at a certain price, and there are going to be 4 neighboring farmers that are interested in renting a cow. So the first number for um, the M stores is going to be the maximum amount of milk. So this store is going to buy up to 10 gallons of milk, and each gallon is going to be 25 cents. And now this probably isn't 25 cents in real life, but let's just stick with the numbers. And after we compute all of this and find the most optimal solution, we have to output the amount of profit or money that Farmer John makes in cents. So let's see here. If Farmer John milks cows number 1 and 4, so that's 13, and that produces 13 gallons of milk, he should completely fill the order for 10 gallons, which is this one, and 10 times 25 is 250, and he can sell the remaining 3 gallons, since 13 minus 10 is 3, at 15 cents each at this store, since this store sells them is willing to buy it at a higher price than this store. So that's a total of 295 cents, and then he should rent the remaining 3 cows for 250, 180 cents to earn 430 more cents, and then if you add that all up, 430 plus 295 is 729. So how should we do this? So right now I'm just going to think of ways that we can solve this. So let's just organize it again. There are cows, and Farmer John can either sell the milk of the cows, or Farmer John can sell the cows altogether. So what is this saying? It's basically saying that if a cow is producing a certain amount of milk, but that amount, the profit you can make from selling that milk, if that's less than the amount of profit you can make from selling the entire cow, then you should probably just sell the entire cow. But the problem is, how do we determine which cows to sell to neighboring farmers and which cows to milk so that you can sell the milk to neighboring stores? I'm, so pause this video if you need any help on that. And an idea that I got to solve this problem is, first what we can do is, for each of these cows, we can just automatically say that we're going to be milking all of them. Never mind the fact that it might be more efficient to sell some of them, we're just going to be milking all of them. So I'm going to show this in a spreadsheet first. Let's see. So there's cow 6, there's a cow that produces 2 gallons of milk, a cow that produces 4 gallons, a cow that produces 7 gallons, and a cow that produces 1 gallon. So this is the cows, and their number of gallons produced. Okay, so first of all, we want to sell a lot of the most of the milk into the more expensive stores. So what we want to do is we want to sort it. So sort, and it's going to be 7. It's going to be descending 4, 2, and 1. Since we want to find which cows sell the most amount of milk, create the most amount of milk, and then we want to um, sell as much milk as possible to the stores that are willing to pay the most money. So there's a store that's willing to buy 10 gallons for 25 cents each, 2 gallons for 10 cents each, and 15 gallons for 15 cents each. So what we probably want to do is, since we want to also optimize it just in case, like there's a lack of cows or there's a lack of stores that are willing to buy it, we want to sort this array as well, so we can get the optimal amount of money just by selling the milk. So we sort this too. So it's 10. We have to sort it by the amount of money paid because we want to make the most amount of money possible, not like sell the most milk. So 15, 15, since that's 15 cents each, and this is only 10 cents each. So Farmer John probably doesn't want to sell to the store unless it's better than selling a cow. And it's more preferable to sell to the store because this store pays a lot more than this store. So after we do all this, what do we do? So for this cow, we're going to be selling all 7 gallons of its milk for 25 cents each. So it's going to be 7 times 25. And now this 25 is going to turn into a 25 minus 7 since no, this 10 is going to turn into a 10, 10 is going to turn into a 10 minus 7 since we sold 10 gallons of milk to that store, and they're only willing to buy up. Since we sold 7 gallons of milk up so far, and they're only willing to buy 10. And then for this one, we're actually going to have to split it in between. So this is going to be let's call this profit. Let's say it's a separate array. And in this one, this cow produces 6 gallons of milk. So we can buy 3 here. So that's 3 times 25 plus 3 times 15, because we can also sell 3 gallons of milk to this store. So this turns into a 3 minus 3, which equals 0. Yeah, let's just say turns into 0. And 15 now turns into a 15 minus 3, right? Because we sold 3 gallons of milk to the store. And now onto this cow. This cow makes 4 gallons of milk each day, so we take out 4 again. This turns in, let's just make it 12. This turns into 8, and this cow, if we sell off its milk, we can make 15 times 4 amount of cents. And then for this one, there's still left. We can still sell some gallons to the store, so it's going to be. It turns into a 6 since we're selling 6 more gallons to the store, so 2 times 15. And then finally, we have 1 times 15 because we can sell the final gallon of milk to the store, so it turns into a 5. So we have it now. We have an array profit, which details the profit if we sell all the milk of each cow. And if there's a lack of stores or there's a lack of milk, we're just going to stop. So there's really nothing to worry about. And let me do these out. So this 7 times 25. So cow profit. 7 times 25 is 175, I think. Am I wrong? 3 times 25 plus 3 times 15 is 75 plus 45, which is going to be 120, I believe. I don't trust my math. 120, okay. 15 times 4 is 60, and 15 is 30, 1 times 15 is 15. And this is going to be by selling milk, by only selling milk. And if this is true, Farmer John can currently make 175 plus 120 plus 60 plus 30 plus 15 cents. And now we go on to part two. Let's just call it part two, so it's easy to organize. And then in this case, Farmer John can sell a cow for a certain amount of cents, detailed here, instead of milking them and then selling the milk. So Farmer John can sell cows at prices, and that's 250, 80, 100, and 40 cents. And what we're going to be doing is we're going to compare these prices with the amount of profit that each individual cow can make. And if a cow is making less profit out of its milk than it can if it's just rented, then it should probably just be rented. And that way, Farmer John will make more profit. But how can we optimize it? So it makes sense that um, if a cow is producing very little milk and making very little money out of its milk, then if it's sold at a high price, if it's rented at a high price, then Farmer John would experience the greatest. Farmer John's money would experience the greatest increase in profit, because the difference between 250 and 15 is a lot greater than the difference between, for example, 80 and 60. That's only a $20 increase. But here, Farmer John is um, increasing his profit by 250 minus 15 cents, which is 235. So how can we optimize it? First, we can sort this. So it's 250, 100, 80, and then 40. And then we can compare it with these values in opposite order. So go through profits opposite order. So 15, 30, 60, 120, 170. Oops, wait, this is all in one place. 50, 30, 60, 120, 175. And we compare it with the sorted values that Farmer John can sell the milk at. So here we see that 250 is greater than 15, so the 15 turns into a 250. That basically means that Farmer John is selling the cow instead of milking it. And here, Farmer John can sell the cow for 100 cents. So we turn this 30 cents into 100 cents, since Farmer John is going to be making a lot more profit this way, and etc. The 60 turns into an 80. Oops. 80. And at this point, it wouldn't make sense to rent out a cow that's already being really efficient and making 120 cents for only 40 cents. We would be losing 80 cents of profit that way. So we don't want to do that, and we just stop there. So we break here. And yeah, that's basically it. And then for add up profit, so 250 plus 100 plus 80 plus 120 plus 175 equals 725. Answer? Yeah, it is. Yeah, that's basically how you do it. And now I'm going to be implementing this idea in code, and you guys can follow along and see how I can use these ideas of sorting and comparing in actual text. So yeah, let's see. Let me open clips. Okay, I'm gonna put this on the left side, put this on the right side, and this on the left, so we can see. Oops, that's strange. Keeps doing that. Okay, give me a second here. Okay, here it is. Okay, there you go. Okay, so first of all, we import java.util and java.io, and we're going to need to use, wait, I think we need to use a scanner, and yeah, we need to use a file reader. Class USACO rental service silver. Yes. And remember that each of the values are going to be like up to 100,000, and that's a really big number for like a scanner. So let's use a buffer reader, and let's use string tokenizer for the lines where we take in 2 inputs, and we need a print header. And after that, we need int n, m, and r. I think, yeah. Here, int n, m, r. And let's see here. So let's create an array that keeps track of like the gallons produced. Let's call it milk. Then let's create another array that's going to be the profit. So it's going to be the profit that each individual cow is making. And each cow is going to have the same index in milk and profit. So it's going to be in the order that it was introduced in the input. We need, so for the stores, I think it would be really convenient to use a tree map. So let's use a tree map that has a key as the amount of cents that it pays for each gallon, and it can store as a value the amount of gallons remaining it can buy. So it's also going to have to be sorted. So let's use a tree map for that. And this is going to let us find stores we should sell the milk to extremely fast. And for rent, let's for the neighbors that Farmer John is going to rent it to, let's call it static array list. Array lists are pretty easy to use. Oops. Okay. And then finally, at the very end, we need the sum. And just in case, I'm going to use a log for the answer. And yeah, that should probably be it. If there's more, I'll just add more. I'm going to be creating my main. Handles the exception, and then see rental.in and out equals new print factor. So for now it's going to be it's going to get the input from console. There you go. Is that wrong? Buffered reader. Is that wrong? Imported java.io. Oh, new. Oh my god. Okay. Pretend that did not happen. And then first I'm going to be initializing it. So what do we do in the init? First we're going to be we're going to get the values of n, m, and r, right? So equals no string tokenize because they're all in one line. Token. I cannot type today. N equals integer dot parsing in dot st.next token, and that's getting each of the values that are stored in the string tokenizer. And then r equals, that's the three values. And then after that, let's set milk. So milk equals new int n. Is it n? Yeah, n cows, m stores, and r farmers. So yeah, it's in order. Int n for int I equals 0, I is equal to n x plus milk at index I is going to be parse int in dot read line, since each of them are going to be on a new line. Let's create that here so you can see it. And okay, so remember here that we have to sort it. So let's just sort it for now. Arrays dot sort milk. Yes. And then we'll set stores. For m stores. And oh, I forgot to mention this. And one thing that I always keep track of when using a tree map, I always consider the possibility that I could enter a key 2 times, which would override the first time I entered the key. And I ask myself the question, would I ever encounter this problem when solving this? And the truth is yes. There could be multiple stores that offer like maybe different amounts that are willing to buy different amounts of milk, but they're willing to pay the same amount of cents for each milk. So what we have to keep that in mind when creating the tree map. So first, int max milk equals integer percent st.next token. Amount of cents equals the same. And then if the stores, if the tree map already contains the key, so there's already another store that's going to be willing to pay that amount. What we can do is we can simply add the amount of gallons each store is willing to pay together, because it doesn't really matter that they're separate stores. They might as well just be one store that that buys more milk, but buys each milk for the same amount of cents. So stores dot put cents, and then oops, stores dot get cents plus max milk. And else you stores dot put cents and max milk. Okay. And then we have to set rent, the array list rent. So rent equals new array list integer. And then add read line. I'm pretty sure these are on separate lines as well. And then we also have to sort this because in rent here, we want to see which neighboring farmers are willing to pay the most amount for a certain cow. So collections.sort for array rent, and then haven't initialized profit. So profit equals new int n, and that's going to keep track of the profit of each individual cow. And yeah, that was a pretty long initialization, and now we'll go to the solving portion. So first, what do we need to do? Well, what we did is first we went through each of the cows from the most amount of milk gallons produced to the least amount of gallons produced. So for int I equals n minus 1, I is greater than 2, n minus 1. So it's a reverse for loop. And then what we did is we found which store would offer the most amount of money to buy a certain amount of milk, and then we just calculated how much profit each cow would make. So let's set a few variables here. So price equals stores dot last key. That's going to be the price that we can sell some milk at, and current is going to be milk of at index I. So basically the amount of milk we can sell. And int gallon is going to be the amount of gallons we can sell it to for this specific store. So store at stores.last key. So it's stores.get price. And then while we need to put a while loop. So while the amount of milk we can sell from this cow is greater than 0. So while current is greater than 0, then what we have to do is we have to see how much milk is remaining, so how much gallon is, and then we have to sell as much milk as possible. So let's say int sold equals math.min current and gallon. Now what that basically does is if there are enough if the store is willing to buy more than the amount of milk this particular cow can make in a day, then all we have to do is just sell all the milk. But if the store is willing to buy less milk than the amount of milk that the cow can produce, then what we have to do is we have to move on to another store up, and we have to continue that until we can't sell any more milk. So int sold equals math.min current gallon, and profit of I plus equals price times sold. And so we're just updating the array here. Gallon minus equals sold, and cur minus equals sold because we added that to the profit, and now we've sold that milk. And so if gallon equals 0, which basically means that the store isn't willing to buy any more milk, then we have to remove that store from the tree map. Source.remove price. And then after this, if stores.size equals 0, so if there aren't any more stores remaining, then we have to break. Not the while loop, but we have to break this for loop. So we can use a trick here where we put start and then this colon. So if we do break start, it's going to break the entire for loop. And then if we don't break star, then we're going to do price equals stores dot last key, since we're going to be setting a new store, which is going to buy milk at the highest price, and gallon equals stores dot get price. And basically, we're just finding the most optimal way to sell the milk for these stores. And we're just making sure that the last value in the tree map is always going to be the largest amount that each store can sell. So if gallon doesn't equal 0, then we have to subtract the amount of milk that we sold to the store. So stores.put price, and this is going to override the previous value, price and gallon, since gallon is going to have uh, sold subtracted from it. And yeah, after this, let's just try printing it out. So system.out.println profit arrays.toString. Make sure that it's been calculated well. And it should be 75, 120, 60, 30, and 15. So let's see if it is. Copy that input. It is. Unit. Interesting. Where else are we printing it out? Oh, it's in the for loop. Well, it doesn't matter. Let's look at the last value. So it's going to be 15. Oh, it's going to be sorted in reverse order. 15, 30, 60, 120, 175. 15, 30, 60, 120, 175. So yeah, it works. Nice. So we're calculating the profit correctly if Farmer John is only going to be selling milk. And after this, what do we do now? So after this, we have in part 2, what we're going to do is Farmer John is going to see if he can sell a cow and make more profit. So first, let's go through each of the values in profit. And since its profit is an array list, no, let's go through everything in rent. So actually, let's go through each value in profit. I think that'll be more accurate. So for int I equals 0, I set some profit. So we're basically looking at how much money each cow makes. Profit.length. And remember that it's going to be in ascending order, so it's going to be the minimum value already. If so, if profit at index I is less than rent.get the last value in rent. So if this value is less than the maximum amount we can sell, maximum amount of money we can make by selling the cow. And we also have to check that the index is right. So if rent.size is greater than 0 and profit of I is less than rent.get rent.size minus 1, then what we can do is we can just update the profit. So profit of I equals rent.get rent.size minus 1. And then we have to update rent because we can't like sell multiple cows to farmers. They only want one cow. So rent.remove rent.size minus 1, and that's going to be the index. Yeah. Let's try printing out again. Oh, and there's one thing that could like just make it more efficient. Profit. So here, let's say that this case isn't true, and that basically means that selling a cow at this index and instead of just milking it isn't going to make any money. But since all of the values after that are also going to be like greater than it, the amount of profit Farmer John can make by selling a cow at a specific index can only decrease. So what we can do is we can do else break, because let's say that here, hmm, so let's say that here it doesn't really make any sense to sell a cow that makes 120 gallons 120 cents for 40 cents. Then it's obvious that the number after that, which is going to be greater than this number, is going to make even less profit if it's sold for this amount. So we can just basically guarantee that the cows after it aren't going to make any more profit. And let's try printing this out. Oh, nice. So we got 250, 180, 120, 175, just like we wanted here. And now to the easy part, we just have to sum these all up. Remember that it has to be a long. Plus n plus equals profit. And then I'm gonna trust that it's correct, and for now, I'm just gonna submit it immediately. There you go, and everything should be good. Java. Oops. Okay, yeah, let's try submitting it. And yeah, as you can see, it works rather quickly for Java. It compiled in like 500 milliseconds for the easy ones and up to 1500. And that's good, yeah. It passed all the test cases. So I hope this video helped. I hope this coding makes sense and this method helped you to understand the problem and like, I guess, what way to approach it. And yeah, thank you guys for watching.